Today our topic is permutation and combinations, which deals with the arrangement and order of the mathematical objects in one's assertion. Like, I have a question for you, that you have English alphabets A, B and C. How much words with or without meaning you can make using all the three at a time? You will definitely say it is A, B, C, A, C, B, B, A, C, B, C, A, C, A, B and C, B, A. For just three alphabets, it is easy to find out that we have 6 words formed by A, B, C. But if the question we will change up to, we have 26 English alphabets, and out of these we need to make words. We need to make words choosing 3 at a time. The question becomes something complicated. To solve this problem, mathematicians introduced a new chapter in mathematics that is known as permutation and combinations, which deals with the forming of words or numbers choosing all or some at a time. The word permutation and combination. I will answer this question. First, let me to introduce about these two words, permutation and combination. Whenever somebody asks you to make words, definitely you have something in your mind, that is repetition allowed, not allowed, or important, or order is not important. Like, if I will choose among A, B, C, ACB, BAC, BCA, CAB and CBA, these are what? 6 words formed by A, B, C. But if I will say I have to choose 3 students, namely A, B and C, then you will say whether you choose ABC, BCA or something else, the combination is same, that we have just choose what? A, B, C. Dear students, I have another question. Say you have 1, 2, 3 and 4. I want to choose two among them to form 2-digit numbers. The question goes like this. Whenever repetition is not allowed, then to fill the first place, I have exactly 4 options. That means I can fill 1, 2, 3 or 4 at this place. But for to fill the units place, I have just 3 options. Why? Because I have already filled up one option in what? In tens place. The total number of such numbers formed by 1, 2, 3, 4, that means 4 digits. That do mean among these 4 digits, using these 4 digits, I need to make 2-digit numbers, and I can make how much? 4 into 3. That is 12. Like 1 2, 1 3, 1 4, 2 1, 2 3, 2 4, 3 1, 3 2, 3 4, 4 1, 4 2, 4 3. How much these are? 1 2 3 4 5 6 7 8 9 10 11 and 12. Now the question is there any way or method in mathematics to find, say for instance, I have 9 digits, 1 2 3 4 5 so on up to 9, and I need to construct numbers of 4 digits. Is there any way, mathematical way, to calculate this? I can say yes. And that method is what? Our today's topic, that is permutation and combination. Before I will start our topic, let me to first introduce you with some symbols used in this permutation and combination. The first one is, you must be already aware of this, that factorial. N factorial is nothing but, it is a natural number n. If n is a natural number, yeah, even I can say n is a whole number, then it is n into n minus 1, n minus 2, n minus 3, so on up to 2 and 1. That means you have to decrease this n up to how much? 1, by decreasing 1, by subtracting 1 from the preceding term. That is, if you have 10 factorial, you can say it is 10 into 9 into 8 into 7 and so on up to how much? Yes, 2 and 1. Like you have 3 factorial, you can say it is equivalent to 3 into 2 into 1. Like you have 2 factorial, it is 2 into 1. 1 factorial, that is 1. You must note this, 0 factorial is always 1. We will prove it later on that 0 factorial is 1 whenever we will get familiar with what? Permutation as well as combination. First of all, our first subtopic is permutation. 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 Yes, it is chapter 7, page number 136. Yes, 35. First of all, fundamental principle of counting, that is fundamental principle of counting. Fundamental principle of counting. That is, if in filling the places, to fill first one you have n options, second you have n minus 1 options, for third you have n minus 2, and for fourth, look at the pattern there. Here, for the first place you have n options. This is the first place. This is second place. For third place, what about earth place? Yes, you are absolutely right. It is n minus or minus 1. Why? Because here you have n minus 3 minus 1. Why? Third step, in your third place, you have to use n minus 3 minus 1. That is n minus 2, of course. For second place, it is n minus 2 minus 1. That is exactly n minus 1. Similarly, to fill the rth place, you have n minus r minus 1. By fundamental principle of counting, which states that to fill first place if you have n options, to fill the second place if you have n minus 1 options, to fill the third place you have n minus 2, and so on. By fundamental principle of counting, which states that total number of ways is n into n minus 1, n minus 2, so on, n minus r minus 1. You have these much options. Like if you have 1, 2, 3, 4 and 5, these digits, and you have to construct 3-digit numbers using 1, 2, 3, 4 and 5. To fill the first place, how much options you have? 5. To fill the second place, you have how much? Since you have already used one digit in the first place, you have only 4. And to fill the third place, you have just 3. By fundamental principle of counting, the total ways is 5 into 4 into 3. That is 5 4s are 20, 23s are 60. You have 60 such numbers formed by what? 1, 2, 3, 4, 5. Using how much digits? 3 digits at a time. Okay? Now, let us start. A question in our book is what? How many it is exercise 7.1, question number 1, page number 138, which states how many 3-digit numbers can be formed from the digits 1, 2, 3, 4, 5, assuming that the repetition of digits is allowed. If the repetition of digits is allowed, like you have 1, 2, 3, 4 and 5, these digits, and what you have to go for? You have to construct 3 digits, 3-digit numbers. That means this. First part is repetition allowed. Whenever repetition is allowed, that means if you have filled 1 in this place, yeah, 2 at this place, you can fill 2 here also and this place also. Whenever repetition is allowed, to fill the first place, you will say to fill first place, we have how much? Yes, 5 options. To fill second place, how much options we have? Not 5, but only not 4, but only 5 options. Why? We have exactly 5 options because the repetition is allowed. And to fill the third place, you have 5 options. Now, by fundamental principle of counting, by FPC, that is fundamental principle of counting, the total numbers are 5 into 5 into 5. Of course, that is 5 cube, which is equivalent to 125. That means 125 numbers are there with the property that they have been constructed using the digits 1, 2, 3, 4, 5, and they are all 3-digit numbers. Now, if the repetition is not allowed, what will happen if repetition is not allowed? We will say if second part is repetition not allowed. Repetition not allowed. If the repetition is not allowed, to fill the first place, we have how much options? We have 5 options. Next, to fill the second place, we have how much options? 4 only. Why? Because 4 only. Why? Because we have already filled it. The first place with some of the digits 1, 2, 3, 4 and 5. Let us assume we have filled, in first place we have filled 3. Whenever we fill 3 at the first place and the repetition is not allowed, you cannot fill 3 at what? The second place. You cannot fill this place by the same 3 because you have already filled this 3 at what? First place. So you have to fill the second place, you have just 4 options, and similarly to fill the third place we have how much? 3 options. Good. Thus by FPC, by fundamental principle of counting, the total number of such numbers is what? 5 into 4 into 3. That is 5 4s are 20, 23s are 60. That is you have 60 such numbers formed by the digits 1, 2, 3, 4 and 5. What? Repetition is not allowed. Another question is, how many 3-digit even numbers can be formed from the digits 1, 2, 3, 4, 5, 6 using if the digits can be repeated. This is question number 2 of the same exercise. At the end of the class, I will ask you a few questions. You must answer them. First, question number 2 is now, how many 3-digit even numbers? 3-digit, important is this thing, 3-digit even numbers. Even numbers can be formed using the digits 1, 2, 3, 4, 5, 6. If the digits can be repeated, digits can be repeated. Digits can be repeated. That means you have to construct what? 3-digit numbers, but the condition should be there what? The number should be even. When does the numbers are even? Yes. Whenever the unit digit is even, we conclude the number is even. Thus, to fill up the unit place, we will say to fill unit place, we have how much even numbers? 2, 4 and 6. 3 options. To fill what? Tens place. We have how much? Look here. Digits can be repeated. Whenever digits can be repeated, you can fill up any of the numbers of this. That means to fill the tens place, you have 6 options. And to fill hundreds place, how much options you have? Exactly 6. Good. Thus, by FPC we conclude, yes, the total number of such numbers is 3 into 6 into 6. Good. That is 36 into 6, 108 probably. Now, if the digits cannot be repeated, if the question goes like this with the same condition that you have 3-digit even number, using digits 1, 2, 3, 4, 5 and 6, but digits cannot be repeated. If the digits cannot be repeated, to fill what you have to fill first? Yes, whenever this restriction is there, you have to make what? The even numbers. So the unit digits must be what? Even. That means to fill this place, you have how much options? This number is even, and this number is even. That means to fill unit place, you have how much? 3 options. Since you have filled any among these 3 in this unit place, so how much you have? Exactly 5. It is 5. To fill this place, you have how much options now? 5 options. And to fill this, you have how much? 4 options. Thus, we will say to fill unit place, we have how much? 3 options. We have 3 options. To fill tens place, we have 5 options. And to fill the hundreds place, you have how much? 4 options. Thus, by fundamental principle of counting, the total number of such numbers is 3 into 5 into 4. That is 5, 3, 15, 15 4s are 60. Now, the question is, another question, I will construct it from the same question. This is question number 2. We have constructed another thing from the same. Now, if the question goes like this, how many among these numbers are with a repetition? We will say total number of 3-digit numbers having at least one digit repeat is equivalent to what? Yes, the total number of numbers, that is 108 minus what? In which you have not the numbers what? Repeated. You have not the digits repeated. That is 60 minus 60. So you have 48 such numbers in which you have what? You have repeated to 1 or yes, you can of course repeat only one digit. You cannot repeat two digits here. But 48 options we have in which we have any of these 1, 2, 3, 4, 5, 6 repeated twice or thrice. I think you are getting it. Next is how many 4-letter code can be formed using the first 10 letters of English alphabet if no letter can be repeated. A nice question. You have how many 4-letter code? 4-letter code using what? Using the first 10 letters of English alphabet, that is A, B, C, D, E, F, G, H, I, J and K. Sorry, it is up to J. Using A, B, C up to what? J, how many 4-letter codes you can make, but the repetition is not allowed. Repetition is not allowed. The repetition is not allowed. We will say we have to make what? A 4-letter code. That means to fill this place, you have how much options? 10 options. To fill this, since the repetition is not allowed, you have already used one among these A to J. You have used one among them at the first place. Now you cannot use it again because repetition is not allowed. So you have just 9 options, and since you have used 2 now, you have only 8 options, and to fill this you have 7 options. Thus by FPC you can say the total number of such codes, the total number of such codes is what? 10 into 9 into 8 into 7. That is, you can calculate it. Okay, calculate. Another is how many 5-digit telephone numbers can be constructed using the digits 0 to 9 if each number starts with 67 and no digit appears more than once. Like anybody having number 99, 0 and so on. You can find out this series to so many people. You have to construct what? The telephone numbers from the digits what? 5-digit telephone numbers. Question is 5-digit telephone numbers. Using digits what? Using 0, 1, 2 up to what? Up to 9. But the condition is there. No digit repeated. No digit is repeated, and every number should start with what? 67. Every number should start with what? 67. Like anybody among you having number 99, there can be a dozen of such numbers in this classroom starting with what? 99. You have to construct the numbers which start with what? 67, but the numbers are what? 5-digit numbers. That means you have to make 5-digit numbers like this. You have no choice to fill up the first place. The only option is you have to definitely fill what? 6 at the first place. So to fill the first place you have what? One option. To fill the second place you have no option other than what? 7, and you have to fill just one option you have. Now the total number of these digits is what? It is 10. Okay, you have used what? 2 among them. So how many digits you have? You have now out of 10 you have used 2. That means you have just 8, and to fill this place you have 8 options. Now you have filled out how much digits? 3 digits, and out of 10 you have filled 3 digits. You have now what? Only 7 digits. To fill this place you have 7. To fill this place you have 6. Thus by FPC, fundamental principle of counting, the total number of such numbers is 1 into 1 into 8 into 7 into 6. You can calculate it again. I think you can go through the next questions. I will show you another question first, that is question number 5. You are already aware about the 10th standard probability, in which your teacher asked you how many outcomes are there if a coin is tossed thrice. What are the possible outcomes? So you will say it is head, head, head. If you have to toss it what? Thrice. It is head, 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 tail, head, 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 tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, and tail, tail, tail. That means you have just listed the sample space. If you have to what? You have to toss a coin thrice. You have just listed it. But I can give this at ease. That means whenever you toss the coin, you have to toss a coin. How much possible outcomes are there? That is of course 2. To fill this place, how much options you have? Either head or tail, and the repetition is allowed. You can fill it in 2 ways. To fill this place, you have just what? 2 ways. Thus, by fundamental principle of counting, the total number of outcomes is 2 into 2 into 2. That is 8. Count these: 1, 2, 3, 4, 5, 6, 7, 8. Thus, this system taught us how to obtain the total number of outcomes whenever you have to go for probability. Now, the definition of permutation. The definition of permutation is: a permutation is an arrangement in a definite order of a number of objects taken some or all at a time. That means permutation is nothing. It is just the rotation of objects taking some or all at a time. Taking some or all at a time. Generally, we denote it by a symbol. Suppose we have an object. Suppose we have n objects. And out of n objects, I am permutizing r objects. That is like you have 10 objects, and you have to permutize 2 objects. You have to permutize. We will say it is equivalent NPR. This NPR is a symbol that you, among the n objects, you have to permutize what? R at a time. You have to select them as well as you have to change their order. So this NPR is a symbol for what? It is equivalent to n factorial divided by n minus r factorial into r factorial. We will derive it that NPR is equivalent to n factorial divided by n minus r factorial into r factorial. Write it. The number of permutations of n different objects taken r at a time, where r lies between 0 and n, and the objects do not repeat, is n minus 1, is n into n minus 1, n minus 2, n minus r plus 1, which is denoted by NBR. Look here, you have n objects and you have to fill up r places. That means out of n objects you have to fill like this: first place, second place, third place, and rth place. I will ask you, if you have n objects under consideration, and the repetition is not allowed. The repetition is not allowed. To fill this place, how much options you have? Yes, exactly n. To fill this, you have what? N minus 1. To fill this, you have what? N minus 2. And so on. To fill the rth place, how much? You have n minus r minus 1. Why? Because up to this stage, you have used what? R minus 1 objects. Out of this, what? N objects. And this is n, and this is n minus 1. Why? Because you have used one digit at this. It is n minus 2. Why? Because before this, filling the third place, you have used what? 2 digits to fill this. Thus, by fundamental principle of counting, you can say the total number is n into n minus 1, n minus 2, so on, n minus r minus 1. That is, out of n, if you have to permutize r objects, npr, that is equivalent to this. You can say it is equivalent to n minus 1, n minus 2, and so on, n minus r plus 1. This is n minus r plus 1, multiply n minus plus is minus, minus minus plus, n minus r plus 1, and then decrease by 1, n minus r, decrease by another 1, n minus r minus 1, and so on. You will reach at one stage, you will reach at what? 2 into 1. But you have introduced some numbers in the product. That is, from this stage, you can say it is n minus r minus 1, dash 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 2 into 1. To get this, you can cancel from this stage to this with the denominator. That means you have just multiplied the numerator and denominator by this quantity. And whenever you need, you can cancel it. What about this? It is n minus 1, n minus 2, going on decreasing up to the stage 2 and 1. Of course, it is n factorial. Good. N factorial divided. What about this? What about this? It is n minus r minus 1, going on decreasing 1 by 1, 1 by 1. So it is what? N minus r factorial. Thus, we have already written npr is what? npr is n factorial divided by n minus r factorial. So whenever you have, like in the earlier question, once we used yes, this question number 3, 4-letter code can be formed using the first 10 letters of English alphabet. That means out of 10, you have to choose what? 4. So it is 10p4, which is equivalent to 10 factorial divided by 10 minus 4 factorial. That is 10 factorial divided by 6 factorial. And whenever you will calculate it, you will find out that question number 4 will become easy by this permutation method. Exercise 7.2 is about to evaluate the factorials. Like you have 8 factorial, you can say it is 8 into 7, 6, 5, and so on up to what? Up to 1. And you can multiply to obtain what? 8 factorial. So there is nothing in exercise 7.2 which is something conceptual. Now another thing is to fill r places if the repetition is allowed. This was what? Whenever the repetition is not allowed. If somebody will say, what about if the repetition is allowed? We will say, to fill the first place, you have what? N options, because repetition is allowed. To fill this place, you have again n. To fill this, you have again n. And to fill this, you have n. How much n's are there? It is n raised power r. Thus, we can say the number of permutations of n objects taken r at a time and the repetition is allowed is n raised power r. Another term, which is if the number of objects you have given has some repetition, like I will say, I will make it clear to you. If you have A1, A2 and B, you have 3 alphabets and you need to construct what? The different words using them, you will definitely say, sir, it is A1, B A2, A2, A1, sorry, it is A2, B, A1, A2, A1, B, B, A1, A2, B, A2, A1. But if I will replace this 1 and 2, you will find out, replace this 1, 2, don't write it, you will observe that you have what? Twice A and B. And you have permutated what? Twice A and B. In this twice A and B, you will find out something repeated. That is what? For 1, if I write 1, 2, 3, 4, 5, 6, you will find out AAB, AAB. That is first and fourth are same. First and fourth are same. You will find out fifth and sixth are same. And similarly, you will find out these are same. That means if there is a repetition, there in the collection, if you have repeated alphabets or repeated entries, what will be the permutation? Write it. If the total number of permutations, write it. If the total number of permutations of n objects when P1 or of one type, P1 is P1 or of one type, like in this you have 2 of one type and 1 of another type. You will say P1 or of one type, P2 another type, P3 another type, and so on, Pk of other type. Then the total number of permutation is n factorial divided by P1, P2, so on, Pk factorial. That is, in this case, what is the total number of permutations? We will say it is 3 factorial divided by how much are of one type? 2. That is 2 factorial. That is 3 into 2 factorial divided by 2 factorial, which is equivalent to 3. That means distinct permutations you have how much? Just 3. Why? Because this is repeated and you can remove it. This is another repeated and you can remove it. This is another repeated and you can remove it. You will find out just 3 are distinct. Just 3 are distinct. How much time we have? These 3 are distinct. So let us go to our topic, that is permutation. It is exercise 7.3. How many 3-digit numbers can be formed by using the digits 1 to 9 if no digit is repeated? That means you have to construct what? 3-digit numbers. 3-digit numbers from 1, 2, 3 up to 9, and no digit is repeated. Now you cannot make the boxes to fill the first place, to fill the second place, and so on. You will definitely say, how many numbers I have? You have 9, n is 9, n is equivalent to 9, and how much you need once? It is 3, so r is equivalent to 3. So you will say the total number of permutations is npr. What is npr? 9p3, which is equivalent to what? 9 factorial divided by 9 minus 3 factorial, which is equivalent to 9 factorial divided by 9 minus 3, that is 6 factorial, and you can solve it. Another question, it was question number 1. Another question, how many 4-digit numbers are there with no digit repeated? I will repeat my question. How many 4-digit numbers are there with no digit repeated? Do you know how much digits we have? Not 9, we have just 10. Why? Because the digits start with what? 0. You have to start with 0, 1, 2, 3, 4, up to 9 symbols. Up to 9, how much symbols you have? You have 10 symbols. So you have exactly how much? 10 digits. 10 digits. Starting with what? 0, 1, 2, so on, up to 9. You have how much? 10 digits. And you have to make what? You have to make 4-digit numbers. 4-digit numbers. Look here. Here is a question. You cannot say 0, 1, 3, 5 is a 4-digit number. It is a what? 2-digit. It is a 3-digit number. That means you cannot start with 0. but you can fill 0 at the other place but not at the first, because this is called what? A 3-digit number. By using another 0 you cannot say it is 5-digit number and this is 6-digit and so on. So to fill the unit, to fill the first place, to fill this place, how much options you have? You cannot fill 0, you cannot fill 0. So you have how much options? 9 options only. Out of these 9, you have filled up now 1. So the total number of permutations is 9 times. 9 times what? How much digits you have now? You have filled up 1 here. You have 9. Why? Now you can include 0. You can fill up 0 at any of the place. 9p. What? How much digits you have? You need 3-digit number. So you have filled up 2 digits for 1 digit and you have 9p2. 9 into 9p2, that is 9 into 9 factorial divided by 9 minus 2, that is 7 factorial. Or you can write 9 minus 2 factorial, which is equivalent to 9 into 9 factorial divided by 7 factorial. How many 3-digit even numbers? This will be the last question for today. How many 3-digit even numbers can be made using the digits 1 to 7 if no digit is repeated? If no digit is repeated, that means you can use 1, 2, 3, 4, 6, 7. 1, 2, 3, 4, 6 and 7. And you have to construct what? 3-digit even number. 3-digit even number. Even number. And another condition is what? Repetition not allowed. Repetition not allowed. Whenever repetition is not allowed, we will use what? The permutation. You cannot say it is and is for or. Look here, a number is even if its last digit is even. I have already told you a number is even if its last digit is even. That means to fill unit displays. To fill, we will write it again because we have a restriction here. To fill unit displays, we have how much options? This one, and this one. That is 3 options. Just 3 options to fill what? The unit displays. And rest of the 2 you can fill up with any of them. But repetition is not allowed. Since you have filled up the unit displays, you have how much digits now? The total was 6. And you have filled up what? The unit digit. So you have now how much options? 5 options. Therefore, n remains to be what? 5 and r is what? You have to just fill what? 2 places, r is equivalent to 2. Therefore, the total number of even numbers is total number of even, condition is here 3-digit. 3-digit numbers formed by these numbers is what? 3 times. What? 5p2, which is equivalent to 3 into 5 factorial divided by 5 minus 2 factorial, which is equivalent to 3 into 5 factorial divided by 3 factorial, and calculate it, get the answer. I hope you have got this topic. I hope you will complete this exercise 7.3 up to the next class, inshallah.